Thanks for watching. Don't forget to like, comment, share and subscribe to.
Today in this video lecture, we are going to solve a Khan University Examination Board Class 11th Alternate to Practical ATP Model Examination Paper Physics 2021. So let's come to our first question of this paper. So here we have our first question. The given diagram shows two different scales on a screw gauge that are main scale and the circular scale, which is not currently in use. And these two zeros, zero of our main scale and zero of our circular scale, does not coincide with each other. This means that there is a zero error. So this diagram represents that there is a zero error and we have two type of zero errors, positive and negative. In a screw gauge, if the zero of the circular scale is behind the zero on the main scale, this means that there is a positive zero error. So main scale reading is 0 in this diagram and we have to find the fractional part, that is least count multiplied by circular scale reading. So least count is 0.01 millimeter multiplied by the circular scale reading is this line that coincide with the datum line. And the value of this line is 3. So our fractional part is 0.03 millimeters. So this is positive zero error. So the correct answer will be option C, 0.03 millimeters. Let's come to our question number 2. We have an observation table for a particular experiment or practical lab. We have to identify that which of the following instrument is used in this observation table. So we have done all these practicals of meter ruler, screw gauge, spherometers and Vernier caliper. So these are the wrong options in which we do not use this type of uh, table. So the correct answer for this question number 2 is spherometer. For the use of spherometer, we have an observation table as mentioned in this question number 2. Now let's see question number 3. So in this question, we have a Vernier caliper, and what we have to do is we have to, in the given situation, the correct main scale reading. So we have to just identify or find the main scale reading. So for main scale reading, we have to check the position of the zero of Vernier scale. So this is our Vernier scale and this is our main scale. So this line 0 has in the cross 31, 32, 33, and 34. So this line is ahead of 33 and behind 34. So our correct main scale reading would be 33, and this scale is in millimeter. So the main scale reading of this Vernier caliper is 33. So the correct answer is option B. Let's come to our question number 4. The tail of a vector A coincides with the head of vector B. The resultant vector of these two vectors will be, so here we have our two vectors A and B. According to the given question, tail of first vector A coincides with the head of vector B. So we have the tail of vector A and head of vector B as given in the question, and we have drawn the vector diagram. The resultant of these two vectors will be. So what we have to do for the resultant of these two vectors can be drawn in this way. So let's draw the resultant vector. So the resultant of these two vectors will be in this way, that A plus B. So resultant can be found of two or more factor by the addition of vector or by using head to tail rule. So option B is the right answer. Then we have question number 5, and the diagram shows a uniform meter scale which is balanced at midpoint. So this is the midpoint, and we have to find the mass of this metallic block. Let's say the weight of this block is W1 and the distance is D1. Similarly, weight of this block is W2 and the distance is D2. So according to the principle of moment, W1 D1 will be equals to W2 D2. W1 is unknown, that is the weight of the block, and D1 is 20. W2 is 50 Newton and D2 is 15. So let's solve this. W1 will be equals to 50 multiplied by 15 divided by 20. So 0 and 0 will be cancelled out. So 5 multiplied by 15. 5 into 15 is 75 and divided by 2 is 37.5. So the weight of this block is 37.5 newtons, and we have to find the mass of that block, that is mg. So G will be divided on the other side of this equation. W over G is equals to mass. So the weight is 37.5 and the gravity is 9.8. So 37.5 divided by 9.8 will be 3.826. 826 kilograms will be the weight of this block. So we have a right answer in option A. So let's come to the question number 6. The total distance covered by a free falling object in 2 seconds. So the object is falling. This means its initial velocity is 0 meters per second. Then the value of gravitational acceleration in downward motion is 9.8 meters per second square. And we have time, that is 2 seconds. And we have to find the distance covered in this time. So according to our second equation of free fall motion, VIT plus GT square over 2. Initial velocity is 0, so this whole term will become 0. So we will have 9.8 multiplied by 2 square divided by 2. So let's multiply 9.8 to 4 and divided by 2. So we will get height is equals to the distance followed by that object is 19.6 meters. So the correct answer is option B. Let's see question number 7. In this question, we have two spheres of different masses P and Q, and they are dropped at the same time and the same height as shown in the diagram. The difference between these two spheres is of their size or mass. they are dropped at the same time and they are dropped from the same height. In this given situation, which of the following could be the correct observation, and its cause when there is air resistance is negligible? So one thing is sure, that if they are falling from the same height, this means that both spheres will reach the floor at the same time. So option D and option C are incorrect. Both spheres reach the floor at the same time. So we have option A or option D, that is the right answer. So air resistance is negligible on both the spheres, and the other is gravitational acceleration is same on both the spheres. So we know that the gravitational acceleration of the free falling body is around 10 meters per second square. This means that in each second there will be a change of velocity as 10. For example, we have a velocity 0 meter per second at the starting point. After 1 second, its velocity will be 10 meter per second. Then in other 1 second, it will become 20 meter per second, and then 30 meters per second. The same case goes for object P as well. So that this is the reason that both the balls will fall or reach the ground at the same time, because change in velocity of these two spheres is same in each second. So the correct answer for this question number 7 is option D. So here we have our question number 8. A bob made of ice is attached to a simple pendulum. So let's suppose we have a sphere or a piece of spherical ice, and this ice is connected to a ceiling with a rod, with a thread. So this makes it a simple pendulum. So if this is made up of ice and ice is melting continuously, so the mass of this sphere is decreasing. Mass is decreasing with time to time, and during the oscillation, the ice bob is constantly melting. That decreases the mass of this bob. The time taken by the first vibration and the time taken by the 50th vibration. So, what will be the difference between them? We know that the time taken by the first vibration or second vibration or 50th vibration, this will be known as the time period. So time period, we know that the formula is 2 pi square root of L over G, or simply we can say that time period is directly proportional to square root of L and inversely proportional to 1 over G. So from these two relation, we can see that there is no relation of time period with the mass of the vibrating body. So for a simple pendulum, time period of the pendulum is independent of mass and amplitude. This means that the time taken for the first vibration, time taken for the second vibration, time taken for the 50th vibration or 100th vibration, the time will remain same. So option C is the right answer. Let's come to question number 9 and 10. In question number 9, the length of the pendulum has become 4 times the original length. So if original length is L, so the increase in length is for L. So as I have mentioned, the independence of time period with the length of the pendulum, that the time period is directly proportional to the square root of length. If we increase the length by 4 times, so this means time period will be proportional to square root of 4L. So if we take this root 4, we will get 2L. This means that the time period has increased by the factor of 2. So by increasing the length with 4 times the original length, this will increase the time period as 2t. Time period will be doubled. So correct answer is option A. Then we have question number 10. If the frequency and the velocity of the wave are 30 and 330 hertz and meter per second, we have to find the wavelength. So the simple formula for the wavelength, for the wave equation is lambda f. So lambda is equals to velocity over f. Velocity is 330 and the frequency is 30. So 330 divided by 30 will be equals to 11 meters. So 11 meters is the right value of wavelength. Option A is the right answer. So here we have our question number 11. The given picture shows a lab setting of an electric sonometer at a school, and this can be used to find the frequency of the standing wave. And the formula for the frequency of standing wave is 1 over 2L square root tension over m, that is the mass per unit length. And T is the tension in the string, and L is the length of wire or thread between these two wedges. Which of the following factor will not cause an error? So the friction in a pulley can cause error. Similarly, by using the tuning fork of unstable frequency, we will get the error in our experiment. And acceleration of the slotted weight. So these slotted weight can, if they are moving or they are accelerating, that can change the tension in this string. So this acceleration of the slotted weight can cause the error in this experiment. So we always use a wire or the thread of uniform cross sectional area. So by using this cannot cause an error in our experiment. So option D is the right answer. Let's see question number 12. In the Melde's apparatus experiment, the frequency of the vibrating string or the standing stationary wave depends on all of the following factors except for the one. So, as we have discussed the formula in the above question, that frequency of the standing wave equals 1 over 2L square root F over M, where this L is the length of thread between two wedges. This F is the tension force, and this is the mass per unit length of the thread. So the length between the nodes is the factor, tension that length between the nodes is the factor, and the tension in the string is the factor, whereas mass placed in the scale pen is also a factor. So this mass placed in the pen will cause tension in that string. So in a way, changing the mass could change the tension in the string and can alter the frequency of that wave. So the correct answer is cross sectional area of the cotton thread. By using any thread with the any cross sectional area, the frequency of that standing waves would remain same. So the correct answer is option D. Let's come to our question number 13. The temperature of the iron ball is 40 degrees centigrade. So we have an iron ball at 40 degrees. It is dropped in a cylindrical thermometer made of copper containing water. The temperature is of water is also 40 degrees centigrade. So this is the temperature of water. After some time, the temperature of the iron ball and the water will be. So as we can see that we have two objects, that is object A and the other substance is B. They are at the same temperature, so there will be a thermal equilibrium between the ball and the water. There will be no net amount of energy or heat transferred between them. So their temperature would remain same, 40 degree and 40 degree. So option C is the right answer. Let's come to question number 14. The given formula is used to calculate a physical quantity that is known as Joule's constant. So assuming the magnitude of denominator and J, denominator is m delta T and the J is 20. So this is the magnitude of m delta T, and for J the magnitude is 20. Then the magnitude of the numerator, and the numerator is VIT. So VIT and the physical quantity represented by J. So we have to find the magnitude of numerator. So VIT will be equals to J multiplied by M delta T. So magnitude of J is 20 and the magnitude of uh, denominator is 36. So numerator VIT will be equals to 720. So the magnitude we have is 720 and 720. And simultaneously we have to identify all the quantity that is represented by J. So as I have mentioned that this J is actually a Joule's constant. So as its name represents, this could be the dimensions of joules or energy. So let's see, uh, let's find the dimensions or the quantity of this J. So let's find the quantity J. So the formula for J as mentioned is VIT divided by M delta T. So V is the voltage, that is joules per coulomb, and I is the current, that is coulombs per seconds, and this time is measured in seconds, divided by m delta T. M is measured in mass, kilogram, and the temperature is Kelvin. So this coulomb, and seconds will be cancelled out. So we will get joules per kg Kelvin. So we have either option A or C right answer. The work done is only measured in joules, and this specific heat is measured in joules per kg Kelvin. This is the SI unit of specific heat. So option A is the right answer of this question. Let's come to our last question of this ATP paper, question number 15. The mechanical equivalent of heat is determined as 6x, and its actual value is 3x. We have to find the percentage error. So we have to apply the simple formula for the percentage error. So it is equal to uh, the actual value minus the uh, determined value. So the difference of this will be 6x minus 3x divided by actual value. So it will be equals to times 100. So this will be equals to 3x over 3x times 100. So 3x and 3x will be cancel out. So we have a percentage error of 100%. So option D is the right answer in this last question.
Thanks for watching. Don't forget to like, comment, share and subscribe to